A lot of developers utilize the Raspberry Pi for prototyping, but in terms of production, there are a lot of options available. Ulderico, could you tell us a little bit about how you guys are taking advantage of the Raspberry Pi?
Well, we have been using Raspberry Pi for industrial applications since the beginning of almost the beginning of Raspberry Pi itself. We saw at the beginning that the Raspberry Pi could also be used not only for prototyping, but for actual products. And we saw lots of people developing, let's say, industrial prototypes of industrial applications for Raspberry Pi as prototypes, using the Raspberry Pi as a prototyping platform. Then, let's say, along the development, realizing that that prototype was actually a nice and fully working application. And then the problem was, okay, how do we bring this application we now have on Raspberry Pi in the field? So we went through this process and started thinking of electronics, let's say, to help make Raspberry Pi usable in industrial environments. Okay. It was something that we were able to do from the very beginning, from the original Raspberry Pi, and then it evolved and became like a kind of a standard thing with the compute module. When Raspberry introduced the compute module that was specifically designed for embedded applications and for the industrial world from the ground up.
Now, your latest product, the Strato Pi Max, is based on the Raspberry Pi compute module version 4. But unlike some of the previous versions, this one is actually modular. Could you tell us a little bit about why you took this approach and how it works?
Sure. The development on the compute module 4 is pretty straightforward, because that's exactly the standard path for developing industrial applications based on Raspberry Pi. The compute module 4, or in general, the compute module offers more flexibility in the I/O architecture you put around the computing core, compared to the traditional Raspberry Pi. So you can replace or reposition the Ethernet USB ports. You can avoid using the SD slot on the Raspberry Pi and do something more. And that's exactly what we've done here. We have a range of our products. The range of our products are based, let's say, half on the traditional Raspberry Pi Model B and the other half on the compute module. So we have both of that. And this new product is based on the compute module. It's specifically the compute module for form factor. And as you said, it's modular because it's expandable. It has expansion slots. Like a traditional PC, we've almost forgotten the expansion boards on PCs, and this is actually what this is all about. It's expandable so that you can tailor the product based on your needs, the I/O based on your needs, and instead of having to pick one product or the other, you can just fit in the proper combination of both, like in any modular product. That's the way it works. In a sense, it is, let's say, functionally a combination of all the other features we have in all our product line, but it can be fitted and mixed and matched to your needs in a single unit.
So what kind of modular boards can you put in there? Are they digital I/O, so on?
Yeah, several things. First of all, well, basically, if you want to have a look at this, that's the enclosure. It's a 9-unit DIN enclosure, standard DIN rail. stuff, and that's what you find inside. That's the main board. What you see here is basically the Ethernet and USB block plus fan, real-time clock, a few LEDs and things like that. This is the core area where you have the Raspberry Pi, an additional Ethernet port, the power supply area, and from here on, it's where you have the expansion boards. The expansion boards are like this, tiny format, that it's a proprietary format that we have developed to fit into this kind of enclosure, basically. So it takes advantage of the way a DIN, standard DIN rail is done. The format is proprietary, although everything that goes through the connector here are standard buses. Basically, the communication from the let's say the motherboard, we can call it, to the expansion boards is done by USB, I2C, SPI, and GPIO. GPIO going directly to the RP2040 or the compute module. The boards, starting from the expansion boards, and we can talk a little bit more of the core architecture. The expansion boards are now we are launching the product with 4 expansion boards. One is a UPS board so dedicated to power supply. It uses an external battery, charges the battery, and also has an auxiliary output UPS power. So you can power, I don't know, an external modem, for example, or external devices with the UPS power that this board provides. This is the only board that fits only in slot 1. That is the first one. It cannot go in any of the other slots. It has to be in slot 1, and you can only have, of course, only one of these. All other boards can fit anywhere from slot 1 to slot 4, and you can have as many as you want. The other 3 boards are digital IOs. Basically, one is digital IO. It's 7 industrial up to 24 volts digital inputs and digital outputs. The digital outputs are pretty flexible. You can combine them in pairs. They can be both push-pull and high-side configuration in terms of. So it's pretty interesting. The digital part is the digital IO part is galvanically isolated from the core unit, and so that's one. Another one is RS-232 and RS-485, so serial communication. And the last one is 2 RS-485 and 1 CAN bus interface. That's that's just let's say the starting point. After that, we will have analog boards and other digital boards. We will have a UPS with super caps, with super capacitors for short. Let's say basically to ensure the unit can go through very short power supply gaps, or to properly shut down, while the UPS board with an external battery can sustain let's say significant power supply downtime and power external devices, while the super cap board will only be used for more limited situation, let's say power outages situations. And another one will be a cellular board with an LTE modem embedded, and other things like that. The other very, very interesting thing about expansion boards is that we will allow third parties to develop their own boards. As I said, the format is proprietary. but we will allow others to develop on that format if they want to create expansion products on that. And finally, the other interesting thing about this kind of modular design is that a lot of our industrial customers have very specific needs. And usually this turns into the development of a custom product for them, based on that's something we do normally, basically creating custom products that are a derivative of one of our standard products. But you have to redesign the whole thing, even for relatively small changes. Here, in most cases, these kind of custom needs will be addressed by simply designing an expansion board rather than the whole thing. And this makes a lot of things, let's say, faster, cheaper, basically more affordable, including things when they get complex like UL certification and things like that. It's much easier, of course, to just certify the delta of an expansion board rather than the redesign of a whole unit. So that's the situation for the expansion boards. I think it's very flexible. Something we learned as a good practice over the last couple of years, 2 or 3 years of, let's say, component supply constraints, where when you have a very complex products, like several of our products are quite complex, have like more than 1,000 components on board, and you're really in trouble if just 1 or 2 components are not available. Because this thing is modular, you may have constraints, but if in some cases these constraints would be confined to just an expansion board, so you would be able to keep going with the rest. Now the supply chain has stabilized mostly, so this looks like something from the past, and that we don't need to care anymore. But you never know. So yeah, this gives additional flexibility. I think it's pretty helpful.
Very good. Now, could you tell us what the Strato Pi Max XS is?
Yeah, the XS is when you don't need all these expansions, but you want to have the features of the core platform, of the core computing platform that we can talk a little bit now. You don't need all the expansions. So we have a smaller version, that's this one, where you basically have only one expansion slot. Okay, that's this one. Okay, for example, it can be, it's not needed, of course. You can go on without it. It's 6 units wide in the same DIN rail enclosure. And has only one expansion slot. You can use basically any of the other boards, but just one, or none if you prefer. So if you're focused and all you need is what's already on the core, so you basically need a powerful edge server with no I/O besides Ethernet and USB, you can live without any expansion boards, or maybe just want to use the UPS expansion board if you want to protect the unit from power failures, and keep going with the main unit. Now the main unit is quite interesting. It's powerful because it's based on the CM4. So you have the CM4 variants with or without embedded eMMC, with or without wireless connectivity, Wi-Fi and Bluetooth, and up to 8 gigabytes of RAM, all the stuff. We've added a lot of other things. As you can see here, we have 2 Ethernet ports. One is a gigabit port. The other one is a 1000 fast Ethernet port with 2 USB slots. The USB slots, as in most of our other products, are independently powered. So you can power on and off each of the USB ports independently. For example, you may want to do that if you have an external USB device that you want to power cycle, and this thing is remote somewhere. You can turn the power down and repower the USB port. And here on the back, you can see there are two SD slots. This uses the same dual SD architecture that we have in many other products, so that you can boot from either one or the other SD slots, and have basically the two SD slots are switched by the microcontroller. So it's like having a person swapping SD cards in the field remotely. You can, for example, if you choose to have the operating system on the SD card, you can have another SD card where you can, while you're running on one, you can install a fresh operating system from zero on the other one, not just on a partition. It's a completely separate thing. Then you can tell the microcontroller to turn off the Raspberry Pi, switch over the cards for the Raspberry Pi, so that when the Raspberry Pi restarts, it starts from the other one. And you can also tell the microcontroller that if the Raspberry Pi doesn't boot properly, it reverts back to the original one. So it's a very, very safe hardware level way of managing the full OS remotely, rather than having to rely on partitioning schemes and other tricks to try to survive an upgrade gone wrong. So that's very useful. On top of that, you also have here, well, I can see here, this is an M2 PCI Express SSD module. Okay, so it's very fast, and of course the size is definitely larger than SD cards. You go easily up to 1 terabyte or so. It's very fast, and this can also be used as the main as the boot storage for the Raspberry Pi, or as an extension, as an extended storage, as a secondary storage. And you can use all these things in combination. Like you can, for example, decide to have everything running here, but still keep the SD card as a fail-safe mechanism for a safe boot in case this one fails, for example. So the way we do that is that we can individually manage the power to all these subsystems. So the microcontroller can shut off the compute module, remove power to the SSD unit, and turn back the Raspberry Pi on, so that the Raspberry Pi will be forced to boot from SD, for example. So all these things, all of this is controlled by an RP2040 microcontroller from Raspberry, again, that's on the motherboard here, with 128 megabits flash dedicated to it. And this one serves basically as the house master of the thing. It controls everything, controls the watchdog, it controls the expansion boards, the power to the expansion boards. The I/O of the expansion boards can go through the RP2040 or to the Raspberry Pi. It's your choice. So you can do a lot of things taking advantage of the RP2040 itself for, let's say, low-level processing of I/O, if you want. So it's pretty flexible. And the great thing is that it's an RP2040. Lots of people have gotten quite used to developing stuff on that. And this is programmable from the CM4 on board. So you can reflash the RP2040 from the CM4 in the field. Again, and that really helps, because you will, it's something that is, it can and will happen in the field, that you have to reflash the firmware. The unit is designed so that it can keep working. The compute module can keep working while the RP2040 is restarting. So this can be done directly from the CM4. Programming, debugging, everything. You can do basically like you had an RP2040, a Raspberry Pico connected to a Raspberry Pi via USB. That's exactly how it works. So it's very familiar. And important thing is that people will be immediately familiar with this programming architecture and the interaction between the Raspberry and the RP2040, because again, it's exactly like a small Raspberry Pico board connected to a Raspberry Pi. You program it the same way, you use the same logic. And in fact, we expect people, we will deliver the unit with a fully functional firmware to manage the whole thing, but it's completely open for people to develop their own firmware on top of that and do their own things.
Now, one of the things that was recently announced was the Compute Module version 5. How's that going to potentially play with this kind of platform?
Yeah, well, it was a secret until a few days ago, I guess, and now it's not anymore. The Compute Module 5 will be compatible, or actually the Strato Pi Max will be compatible with Compute Module 5 from the beginning. So when the CM5 will actually be released, this version of Strato Pi will be compatible with that. That will add more power, basically more raw computing power. As you see, we already have a fan here. The fan may not be strictly required for the CM4, but will definitely be very good to have with the CM5, because basically if you use the CM5 pushing it to its limits, it will get warm indeed. All the area here is free and open, so you will be able potentially to have a CM5 with passive heat sink on top of that. That will be directly in the airflow of the fan, providing efficient, effective cooling. So that's compatible with that. And there is another thing about talking about compatibility with different CM versions. There is another module that's called Zimbit. I don't know if you have heard of that. It's basically a compute module 4 with an additional board underneath it. It retains the same form factor, the same connectors of the CM4, so it's fully compatible if you have room vertically on the board. And that's basically a, let's say, security hardened CM4. So it has an internal microcontroller that protects the boot process and the flash, the onboard flash. So it's specifically aimed at this kind of, let's say, hardened software platforms. And that the Strato Pi Max is also compatible with that. It has been designed to be compatible with that from the beginning. That's interesting, because the use cases for our customers on this kind of product, we expect to be pretty, let's say, wide. So there will be people who will need a lot of performance, and the CM5 will definitely be good for that. Others who may be more focused on expansions and not really care of performance, so the CM4 would be way more than enough. Others who are particularly concerned of, let's say, the protection of the unit, of its boot process, the integrity protection of the unit, and for those, like solutions like third-party solutions like the one I mentioned would be interesting.